Null and alternative hypotheses, the foundation of every hypothesis test. Hypothesis testing works a lot like a courtroom trial. In a trial, the defendant starts with a presumption of innocence. The prosecution must present enough evidence to overcome that presumption beyond a reasonable doubt. In statistics, the null hypothesis is like innocence. It's the default assumption of no effect or no difference. The alternative hypothesis is the claim we're trying to establish, like guilt. And our evidence comes from the data we collect. Let's lay out the two hypotheses side by side. The null hypothesis, H0, is the claim of no difference. It represents the status quo and always contains an equals sign. This is what we attempt to disprove. The alternative hypothesis, H sub A, is the claim that there is a difference. It represents the research claim and uses inequality symbols, not equal, greater than, or less than. This is what we're trying to find evidence for. Let's look at a concrete example from the textbook. In the 1970s, men aged 20 to 29 had a mean body weight of 170 pounds, with a standard deviation of 40 pounds. We want to test whether the mean weight has changed. The null hypothesis says mu equals 170, meaning nothing has changed. The two-sided alternative says mu is not equal to 170, allowing for either an increase or decrease. Alternatively, if we suspect weight has only increased, we can use a one-sided alternative. Mu is greater than 170. Two-sided tests are more common in practice because they're more conservative. Let's compare one-sided and two-sided tests. A one-sided test looks for an effect in only one direction. The alternative hypothesis uses greater than or less than. It has more statistical power for detecting effects in that specific direction. A two-sided test checks for effects in both directions using the not equal to sign. It's more conservative, but is the most commonly used approach in practice because we often don't know the direction of the effect beforehand. Hypothesis testing follows a systematic four-step procedure. Step 1, state the null and alternative hypotheses. This is the step we've been learning about today. Step 2, compute the test statistic from your data. Step 3, find the p-value, which measures how likely your results are under the null hypothesis. Step 4, draw a conclusion. Reject or retain the null hypothesis based on the evidence. We'll cover steps 2 through 4 in the next concepts. Let's recap. The null hypothesis H0 claims no difference, while the alternative H sub A claims there is a difference. Think of it like a courtroom, innocent until proven guilty. Two-sided tests are the most common approach, and hypothesis testing follows a systematic four-step procedure that we'll continue to explore in the next lessons.